Right. Let's get this started. Well, good morning, everyone. My name is Nick Bryan. I'm a sales engineer for Long in our Fort Collins office. Today, I'm going to be presenting on the Friedrich VRP unit and its ability to help lower our central DOAS. Bascom, who is going to co-present with me today, was feeling under the weather, so I'm going to end up running through the presentation here. So it might be a little choppier than if he was going to do it, but still be able to get you the information and the benefits that we can provide with the VRP unit. So Friedrich just developed their VRP unit, trying to come up with a way to pair both the VRF technology, which is newer technology where we're better able to match part load to the conditions you're seeing in your space, while still maintaining a modular install approach that minimizes the amount of outside air, ductwork, dampers, and penetrations that you have to have. So in doing that, they were able to come up with the VRP unit, which also is able to introduce outside air to the space when you need it while the unit is running. And here's kind of the general overview of where this unit came to be. On the left side, you have your kind of standard VTACs and VTACs. One of the benefits of these, they're typically economical. They're easy to install, easy to maintain and repair. Some of the pros that generally come with these is the efficiencies that come with these units. Generally, they're single speed scrolls. So your compressor is either fully on or off, and also the noise too. And just one other two con is that people generally view them as just a little less high end and a lower end hotel if you're staying in one with a PTAC or VTAC. On the other side of the chart here is you have the VRF and 4-pipe systems. These are generally considered high-end systems that provide very precise comfort cooling and very high efficiencies. The downsides of these systems generally are the high cost of installation, the complexity to make sure that the system's operating properly, and the high initial cost. So you're going to end up paying a little bit more on the front side for those efficiencies and the benefits. That's where Friedrich came up with the VRP unit. We're trying to marry these two things where you're still maintaining your economical cost and ease of install while having higher efficiencies and better sound levels to provide a better comfortable space for the customer. And with the VRP unit, they're able to focus on all the 4 primary things that we're worried about when it comes to maintaining a comfortable space, and that's whether it's cooling in the summer, heating, bringing in fresh outside air, which is becoming more and more important in our industry every day, and also humidity control. And while it's not always important in Colorado that we're so worried about humidity, it is something that they have an ability to monitor, which I'll get into a little bit later. So with the VRP, you're able to see essentially here their efficiencies and the ability for it to increase in efficiency as you're going down in capacity. And that's really the whole name of the game when it comes to improving efficiencies is matching your part load. Majority of the time, as you guys all know, we're not running at full capacity. It's not a design day. In Colorado here, it's probably 70 to 80 degrees. We might get us a thunder new afterstorm, but it's not going to be too humid. So with the VRP, you're able to slow that compressor down to match the cooling load or heating load that you have on there without providing more than you need, which is how we're able to drive our part load efficiencies. Another benefit is also that we're able to overdrive these compressors about 20%. So if you do happen to have, a design day or design day that even, exceeds what you're expecting, that extra 20% that this compressor has will be able to help get you through that in a comfortable space without sacrificing it. Another benefit of the VRP is its ability to cool down to 0 degrees. So typically with most heat pumps, as you know, they're cutting out around 36 to 40 degrees, depending on the manufacturer. At that time, you're typically switching over to electric heat. So your COP's, essentially 1. So there's not a ton of efficiencies saved versus a compressor system. We're able to take advantage of the refrigeration cycle. With the VRP, you're also able to take heating all the way down to 0. So we have plenty of days here in Colorado where we're sitting below 40, and typically in most systems we'd be kicking on electric heat. It works fine, but just the efficiency of electric heat is not nearly that of a compressor. So by being able to have the compressor continue to provide heating all the way down to 0, you're able to still see those efficiency savings while maintaining a comfortable environment. And this is some bin data where they came up with an energy analysis saving. This is for Minneapolis, so it's a little colder than Colorado here, but also kind of gives you a good idea of the savings that's available in a cold weather climate where you're going to be heating quite a bit of the year. So in Minneapolis, they've found that the VRP operational savings based on their local energy costs were about $385 per year. So while the VRP does cost more upfront compared to your standard VTAC or PTAC, the savings ends up adding up pretty quickly for the owner. It's only going to happen as energy costs continue to escalate. So if you'd like to see, this is based on bin data that they had. So if that's something you'd like to see, please reach out to your local sales engineer and we can get you this data if you'd like to review it further. And here we're just discussing generally the size of the VRP unit. They recently introduced a size 7 for the smaller spaces, and then they'll go all the way up to a 3-ton unit. And with that, you can see based on the cooling BTUs, the min and max, you can see even a 7,000 BTU unit is able to overdrive and really go up to 10,000 BTUs. So you're able to see both the capacities that we have here and then the SEERs, which is generally what these units are getting rated against, where we can go up to as high as 20 SEER on these. And then also kind of, as I was discussing earlier about the electric heat, the COP of most of these units is above 3. So again, you're having that energy savings between 0 and 40 or whenever your typical heat pump cuts out. The VRP unit is still able to continue operating all the way down to 0, and you're getting those efficiencies instead of having to turn on your electric heat. And here's a general overview of the air path of the VRP unit. One thing I'd really like to take a minute to focus on is the ability to bring in outside air through the unit, condition it, and bring it to the space. By doing this, you're able to reduce the size of your central DOAS system. So maybe you're just providing outside air to your corridors and you're letting the VRP unit provide your outside air at the zone when you need it. And not have to provide extra DOAS, if it's an unoccupied room. So in the VRP unit, the outside air will circulate through the condenser coil and exhaust back out. But with this unit, they have the ability to provide up to 140 CFM of fresh outside air through 2 fans that you can see comes through the outside air, goes through a filter to make sure you're not introducing particles into the space, mixes with the return air, and then is conditioned at the coil. So a lot of VTACs and PTACs will just have a passive opening. So essentially what the supply fan is able to pull out is what you're going to get for your outside air. With the VRP units, you actually have dedicated fans that will turn on and guarantee that you're bringing that air into the space. And in Colorado, it's not always such a big deal, but one option that they do have if you're designing in a humid climate is that they have hot gas reheat available. So they'll be monitoring your return RH coming back to the system, and then based on whatever your set point is, heating that back, not overcooling the your outside air, and then bringing it back up. So with their ability to monitor the RH of the system, they can more effectively use the modulating hot gas reheat circuit. Again, something we not always see here in Colorado, but is available as a feature for this unit. On this slide, we're discussing and kind of gives a good overview of 2 systems. One on the left side being either a traditional 4-pipe fan coil system or VRV unit, where your outside air is being brought through the entire system. If it's a VRV system, your refrigerant piping is running throughout the building, where you're having to take into considerations of ASHRAE 15, and then also just that extra DAC work comes with dampers, fire dampers, additional controls to maintain all that, where the VTACs on the right simplify the system and provide a modular approach. One benefit of this also is that if one VTAC goes down, you might have just one room down, where in a traditional VRV or 4-pipe system, your DOAS, if that goes down, now your entire system's down. So this provides some flexibility with your design, in that if one piece of the equipment goes down, your whole building isn't suffering. Another benefit too is opening up rooftop space, which having more leasable space is the name of the game for a lot of building owners and being able to drive their own profits. So by cleaning up the roof a little bit, not having as much equipment up there, you're able to utilize it for other things, amenities like a pool that they're showing here, patio, or really whatever the owner wants to do, but they can qualify that as leasable square footage instead of it being a mechanical room. So just another benefit of being able to reduce your outside air needs through a centralized system. And this system, or this slide, generally just talks about the various needs of, you know, common systems that we're seeing and the complexity involved. Also at the bottom, you can kind of see the dollar signs in terms of what these systems typically cost. When you're doing a heat pump system, you're paying for your individual compressors, not in addition to your condenser pumps, your cooling tower, air handlers, and a full DOAS. So that generally drives your cost pretty high, similar to a 4-pipe system. With a VRV, you're able to minimize typically how much ductwork you're bringing in, but you still have additional complexity and a system that ends up costing a little bit. Where the VRP, it kind of finds that sweet spot of still being able to bring in outside air and provide a comfortable space while driving down first cost for the owner. And with that, that's our overview of the Friedrich VRP product. Next week, Justin will be talking about packaged rooftop units with Valent and their ability for factory mounted controls. Thanks for your time today, everyone, and hope you have a good day. Thank you.